Hello everyone, welcome back to my general chemistry mini lecture. Today our topic will be the density of gases at different conditions. First, we will talk about how to calculate the density of a gas at STP. The STP stands for standard temperature and pressure. So it's 0 degrees Celsius and 1 atm. And at STP, the volume of 1 mole of any gas is 22.4 liter. It's called a molar volume, and this number actually can be calculated from the ideal gas law. And we know the mass of 1 mole of gas is the molar mass in grams per mole. So we can have this formula of the density of a gas at STP equals molar mass divided by molar volume. That is molar mass divided by 22.4. Unit is grams per liter. So with this, using this formula, we can calculate density of any gas at STP, just one step. For example, what are the densities of argon and oxygen at STP? Both are gas. So we can just find the molar mass first and then divide it by 22.4. For the argon, molar mass is 39.95 grams per mole. That is from the periodic table. And then the density of argon at STP will be the molar mass divided by 22.4. So 39.95 divided by 22.4, that's 1.78 grams per liter at STP. For oxygen, the molar mass is 2 times molar mass of oxygen, with 32. And then density of the oxygen at STP will be molar mass 32 divided by molar volume 22.4. And the answer is 1.43 grams per liter. And this is at STP, the density of oxygen. So to calculate density of a gas at STP, it's very simple. You just need to know the molar mass. Now, what about the condition is not standard temperature and pressure? Then we need use a different formula. So slides, we will talk about how to calculate the density of a gas at any other conditions. We know the PV equals nRT is the ideal gas law. P is pressure, volume, and then mole, N is mole, and R is ideal gas constant. T is the temperature in Kelvin. Based on this ideal gas law, this mole is actually the mass divided by molar mass. And then we can rearrange this equation. Mass divided by volume, m over v. Mass divided by volume is density. And that equals pressure times molar mass divided by RT. So that is a general formula to calculate the density of gas at any conditions. And also based on this formula, if you do another rearrangement, you can calculate molar mass. So molar mass will be density times R times T divided by P. That's pressure. So use these two formula, we can calculate density, and also we can calculate the molar mass if you know the density. Okay, I'll give you some examples here. First, this is one example. Calculate the density of dinitrogen monoxide. It's also called a laughing gas at room temp and 2.16 atm. And we know the formula to calculate the density at any condition is the P times molar mass over RT. So R is the ideal gas constant, can be different if you use different unit of the pressure and volume. So international unit R equals 8.314. But the very common used R is actually 0.08206. The unit of pressure is atm. The unit of volume is liter. For all the R here, the moles unit must be mole and the temperature must be Kelvin. Okay, that's the same. So if you use the torr as the unit of pressure, use the liter as the unit of volume, R equals 62.36. Okay, so that's more common R used here, and this is the international. So now we need to know the molar mass of this laughing gas. We have the formula, so we can calculate the molar mass. 2 nitrogen plus 1 oxygen is 44.02 grams per mole. We also need to convert this temperature to Kelvin from degrees Celsius. So the formula is Kelvin equals degrees Celsius plus 273.2, that's 298.2 Kelvin. Now we can plug into this formula. So we have the density equals, this is the pressure in ATM. So now if we use the ATM here as pressure, then R will be 0.08206. So you see that's R here. So we plug in the pressure, molar mass, we just calculate the molar mass 44.02 divided by R 0.08206 because we use ATM as the unit of pressure. Then this temperature in Kelvin 298.2 we just calculated here. So the answer is 3.88 grams per liter. The laughing gas density at this condition is 3.88 grams per liter. Another question, similar, what's the density of sulfur hexafluoride at 102.4 degree and 524 torr? So you may notice that pressure is torr, not ATM anymore. So we will use different R in this calculation. Okay, again we know the formula is the same. Okay, and then R is also have different choice. So when we have torr here, we will use this 62.36 as R, and we also need to find the molar mass. Molar mass of the sulfur hexafluoride is 1 sulfur plus 6 fluorine, and that's 146.1 grams per mole. And then the temperature need to change to Kelvin. 102.4 plus 273.2, we calculate that as 375.6 Kelvin. That's the temperature. Then we can plug into this formula. The density is pressure 524 torr, and then that's molar mass, we calculate that, divided by 62.36 because we use torr as unit of pressure, so we need to use this R. And then temperature, that's 375.6 Kelvin, and then we can calculate density is 3.27 grams per liter. This is the laughing gas density under these conditions. Okay, so now I will give you an example to calculate the molar mass if you know the density. Okay, let's look at the example to calculate the molar mass of a gas from density. So this is the question. Calculate the molar mass of an unknown gas if its density is 0.173 grams per liter at 23.5 degrees Celsius and 1.05 ATM. So we know the temperature, we know the pressure, we also know the density. Then you can use the formula. Molar mass equals density times RT divided by pressure. And R, it's still have 3 different R to choice. Actually, there are more than 3, so this is most common. And since we have ATM as the pressure unit, so we still use this 0.08206 as R. And then we also will calculate the the temperature in Kelvin. So 23.5 plus 273.2. Convert that degrees Celsius to Kelvin, 296.7. Then plug in to this formula. Density is given 0.173 times R, I just mentioned, right? We use ATM, then we use the 0.08206 times temperature. We just calculate divided by the pressure in ATM. So the answer is 4.01 grams per mole. So that's the molar mass of this unknown gas. This looks like it's the helium because the molar mass of helium is 4. Okay, we have another example. This is the question to identify unknown gas. And this is the question. An unknown gas density was measured as 1.903 grams per liter at 37 degrees Celsius and 1,315 millimeter mercury. Based on other analysis, the gas could be hydrogen or carbon monoxide. Identify the gas based on the measured density. Okay, so this question, we still need to calculate the molar mass because we have two choices. So we first calculate the molar mass, and then we compare the molar mass with the molar mass of these two possible gas. Then we can identify which one is the unknown. So that's the strategy. Okay, so we still use the formula, molar mass equals density times RT over pressure. And then R, still same. And then we will calculate the temperature in Kelvin again, right? So 37.0 plus 273.2. We get 310.2 Kelvin. And then we can plug in to this formula. Density 1.903 times 62.36. This because we have millimeter mercury. You may wondering, oh, that's torr, but millimeter mercury and the torr actually it's the same unit. So 1 millimeter mercury equals 1 torr. And so we still use this 62.36 as R and times the temperature in Kelvin, and then divided by the torr, or you can say millimeter mercury. So then you can calculate the molar mass of this gas is 28.06 grams per mole. Now, it's very obvious, right? So because molar mass of hydrogen is 2, molar mass of carbon monoxide is 28. So the carbon monoxide is the unknown gas. So in this way, we can identify the unknown gas. Okay, that's all the example of this density calculation of gas at different conditions. If you have any questions, please let me know. Okay, good luck.